All right, so we're going to be starting a new chapter on trigonometry. And before we get started, though, I want to review something that you probably learned in maybe high school geometry or at some point in your life. I'm sure most of you probably have had some trigonometry as well, but I want to just review these special right triangles. Okay, the 45, 45, 90 triangle and the 30, 60, 90 triangle. All right. So in general, the 45, 45, 90 triangle is just basically half of a square. You take a square and cut it in half diagonally, and what you end up with is 45, 45, 90 triangle, right? It's an isosceles right triangle, which means that the two legs of the triangle are equal. They're the same length, all right? And then in the hypotenuse, then we can find from the Pythagorean theorem. So if we take just a very simple case where the two legs are 1 and 1, right, then we can find the length of the hypotenuse with the Pythagorean theorem, right? A squared plus b squared equals c squared. So c squared is 2, right, because 1 plus 1 is 2. And then square root of that to find c gives us a hypotenuse of square root of 2. So the ratio of these sides, this 1, 1 square root 2 ratio, is the same for all 45, 45, 90 triangles. Okay, isosceles right triangles. And basically, to get any other isosceles right triangle, we just scale it up or down. Okay, so I want you to understand how to do these problems using a scale factor, because we haven't actually learned trigonometry yet. Okay, so pretend like you don't know anything about trigonometry when you're solving these problems. So you can see in this first example, I have it's a 45, 45, 90 triangle. The only difference between this basic one is just that the one of the legs is 4, okay, instead of being 1. So that just means that the whole triangle is scaled up by a factor of 4. So the scale factor is 4 because the ratio of these corresponding sides, this leg on the triangle in example 1 versus the basic 45, 45, 90 triangle, right? It's scaled up by 4 to 1. So the scale factor is 4 essentially. So to get the lengths of the other sides of the triangle, we just basically take this basic 45, 45, 90 triangle where the ratio of the sides is 1, 1 square root 2, and we just scale those sides up by a factor of 4. So you can see that side B just becomes 4 times the corresponding side in this basic triangle. So it also has to be 4. And then we're scaling up the hypotenuse also by a factor of 4. So we're going to take the square root of 2 and scale it up by 4. So multiply it by 4. So the hypotenuse has to be 4 square root 2. Okay, just using a scale factor, right? We're scaling all of the sides up by a factor of 4. Okay, so let's take a look at example 2, which is probably why you clicked on this video, to go through example 2. So we first of all just need to find the scale factor, right? Which is essentially the ratio of the side that we're given and the corresponding side in the standard, 1, 1 square root 2, 45, 45, 90 triangle. Okay, so let me see, get my pen working here. So let's figure out the scale factor. Scale factor. All right, we just want to take the ratio of the side that we know, which is 5, to the corresponding side in this standard 45, 45, 90 triangle. So the hypotenuse is square root 2 there, but we're scaling it up, right? So the ratio is 5 over the square root 2. So we're basically scaling up that basic triangle by a factor of 5 over square root 2. And so then we can just find the other sides by using that scale factor. So side A is one of the legs. The length of that leg in the standard 45, 45, 90 triangle is 1. And so we're going to scale up 1 by a factor of 5 over square root 2. Okay, which is just 5 over square root 2. Now, oftentimes, it's kind of been a long-standing tradition in mathematics to rationalize a denominator. Now your book doesn't, they do a lot of problems and they leave square roots in the denominator, which I think, I honestly think rationalizing the denominator is a little bit archaic because at one time before calculators existed, it was difficult to divide a number by a irrational number because the decimals go on and on forever, and if you tried to do that by hand, it would be tougher to get it with any accuracy. So it's normal, or it's common in mathematics to rationalize a denominator, and we can do that by multiplying by square root 2 over square root 2, which is just 1, right? So we're not really changing the value, we're just changing the form of this value. So an equivalent form is 5 square root 2 over 2. So if you were actually trying to calculate that by hand without a calculator, it's easier to take 5 times the square root of 2 and divide by just a simple 2. If you imagine doing long division, it's a lot easier to divide by 2 than it is the square root of 2. Okay, but I think it's fine if you leave your answers in the form where you of like 5 over square root 2. It's fine if you don't rationalize the denominator. For me, anyway. Okay. All right. So then, now in the 45, 45, 90 triangle, A and B are the same, right? Now, and so we're just going to get, again, 5 square root 2 over 2. Okay. Or you could write it 5 over square root of 2. All right. So there you go. We've solved for all the remaining sides in this triangle, and I'll meet you in the next video.